Okay, I guess let's get started. This is Etisham from Quick Start. Welcome to the webinar on implementing network device security. We have James Asutaku with us. He's an expert in and a technical trainer and a consultant, and he has been at it for almost 2 decades. So, James, take it away.
So welcome to this webinar. Thank you for being able to make it and on time. We're going to begin a little bit about me. I have my information on there for you. If I was over the phone, if I didn't have my picture and I had time, I'll pretend to be Japanese and see how much fun I can have with that. The name, of course, is from Cameroon, which is in West Africa, and but I've lived in the States ever since '97, so it's pretty much home now. But I grew up in Cameroon till I was about 17, then I moved to the US and lived there. In time, I've been able to acquire a few certifications, and I've been, as was mentioned, I've been a trainer since 2001 up until now, and I hope everyone can hear me. But anyway, I've been a trainer up until now. In the meantime, doing consulting as well. Recently, focusing heavily on virtualization and security. As you've paying attention to the actualities and how things are going, you can understand the importance of security. Hence, the importance of this training today. You think about how many people are vulnerable and susceptible to attacks, but really do not know because the information is not presented to them. So in this training today, we are going to talk a lot about how to secure your Cisco iOS device, your Cisco routers, your Cisco switches, and any other Cisco device that uses iOS as its main software or as its main operating system. By the end of this course, you're going to be able to prevent anonymous access to your Cisco devices. Many of you surely know when you get a Cisco device, it's wide open as far as security is concerned. So if you do not configure security, it is definitely vulnerable to attack. So we're going to start with the basics, how to secure access to privilege exec mode, which is a special mode in your router, how to configure console access or secure console access, and how to secure remote access. These three options were chosen because they are your primary methods of accessing your Cisco device. So we'll see how to block that entry in the basic form. Now that we have been able to block the entry to the device, how can we make our device stronger? Hence your second portion, which is implementing device hardening. We'll look at things like securing unused ports on switches, a very important section. I think you'll find it pretty interesting. Unless you've sat in another Cisco training class, you're going to see the utility of understanding this port. So we'll talk about port security, how to configure port security, and how to verify port security. We're able to stand up a lab environment just for you, so you'll be able to see this at work, right? We're going to perform the actions on an actual router. So you, through virtualization, will be able to see these commands firsthand as a demo. Then we will just talk about disabling unused ports on your switches, how that is done. And then now we'll get into the application level of security, right? You've hardened your hardware, blocking it on layer one, but how about the higher layers? So we'll talk about access control lists so that you can prevent some programs from running. We're going to talk about how to prevent some services from running on your routers and switches. You do know that Telnet very vulnerable to attacks. So you may not want Telnet at all in your network environment. Hence, what do you do? We'll talk about how to disable services, maybe HTTP as well, because you know that you can connect your router to a web interface. So how can you prevent HTTP and allow only HTTPS so that someone inadvertently is not calling HTTP and then transferring all your configuration information in clear text? And then as time permits, we may be able to look at AAA radios and well, it says NAS, but it should say NAT, so network address translation. So we will have an overview on those technologies and how they work, how to use AAA for authentication, authorization, and accounting on a local router, how to have it work with a radio server, That way, if Radius is connected to Active Directory, you can now use the Active Directory accounts. And then your NAT rather, how to do network address translation. So as time permits, because you always know when you're dealing with the live environments, there could be irregularities, but as time permits, we may be even be able to get some additional value to your training today. I love questions. However, we will allow questions the last 10 minutes of the training. But if there is a short question or something that really is holding you back from understanding the explanation, please, by all means, ask at that point. It may help spice up the conversation. If anything, it could help direct the conversation even better. So I'm not against you asking the question when you think about it. Just remember to unmute. So you have 3 basic lessons you'll be going.
Wait, James. So people do not have the option to talk during this webinar, like they have limited access. So we've
Okay.
got a Q&A box, we've got a chat box. Feel free to just type out the question in the chat box or the Q&A box, and I'll deliver it to James right away.
I like that even better. Thank you very much for that. So what are we going to cover in this 50 minutes webinar? First of all, we will look again at securing administrative access to our device, our switches, our routers, implementing device hardening, and implementing advanced security. So let's start with our very first lesson, securing administrative access. The first part of this is how to protect entering our router. See, when you purchase a router from the store, whatever your favorite store is, you bring it into the work environment, or you bring it into your small business, your home business maybe. All you have to do is go to the back of the device, connect, whether it's a USB or a serial port, connect it, then connect the other end to a laptop, and then you can, through a program like PuTTY or Hyper Terminal, you can go in and configure their interface, right? Now, when you land into your Cisco device, Cisco has special modes. There are 3 main modes on a Cisco device, an iOS device. First, there is an introductory mode called your exec mode. Everyone has access to the exec mode. Once you have access to an interface on the router, that's the first mode you land into. You can run basic instructions. You can maybe ping for and test for connectivity. So there are commands that run on that level. However, if you plan on configuring or viewing the configuration on that router or switch, there is a second mode called your privilege mode. In that mode, what you do, you have to run a command that takes you into that mode. And we're going to see all of this, of course. And once you're in there, maybe you're trying to change a configuration. So with changing the configuration, you will go into a special mode called your global configuration mode. Why do we stress and talk about all of these? Because as part of security, you can protect every one of those layers. Yes, you can even protect that very first mode that you land on. But to be able to do that, you would have to protect something called your console. So we'll talk about the console later. But first of all, let's see how we can protect that exec mode. I'm going to try to bring up my lab environment. So I have a basic lab here set up for you, where we have your PC1, which is the machine that we can assume we're sitting on, right? And then it's connected to a switch that's connected to another switch that goes to a router. And then on that switch, there's a PC2 communication. As you know from your network training, right now, as long as communication is happening in here, we have no problem. We should be able to ping each other. So the environment should have been set up already, and it's been tested already. Now we would have to click on our router device, and we can see some of the configuration options. So I'm going to give that a moment to load. And what we will do, we'll look at some of these modes. Then we will talk about how to protect these modes. Try to click again. To bring up a terminal that allows us to do some configuration. Let me see if I'm missing the window. Oh, there it is. All right, so it was just opened up somewhere else. So I would say allow. All right, now here's my question. Are you able to see a terminal?
No.
No? Okay. Let's see how I can share that window as well. Um, I see. Okay. So I'm going to stop my sharing and see if I can include my terminal window. I
Yeah,
may have to
you'll have to stop sharing for a bit and then.
all right. Okay. So this is my router one interface then. And so we've talked about different modes. And let me see. All right. So this is your user mode, right? So anyone that has access to the device gets a hold of this mode. There are a few commands you can run here once again that allow you to view configurations or not view configuration, rather, but test connectivity and things like that. So this takes me to my next mode, which is my privilege mode. We call it a privilege mode because normally the command I just ran was en, but the full word for that is enable. So it allows you to be able to perform administrative functions. That mode is the mode you can protect, is one of the modes you can protect. So that's your enable mode, as some would call it, or your privilege mode. Another mode is your global configuration mode, which allows you to configure your device. Now, in this mode, you will know I'm in a different mode because the prompt before your pound changes. Yeah, so that'll be helpful for you to see the configuration that we're doing. So first question, how do we protect that privilege mode? So I'm going to set an enable password, right? Since the command you put in is enable, so I would say enable password. And then let's say the password is password123. All right. So I can now leave this mode. And from then, I'm now going to, since I type enable to come in, I would say disable now. And let's get out. So I'm back to my user mode. Let me type enable again. So now you would notice a difference. Previously, when I typed enable, it took me straight into the system. Now I'm going to type enable again, and you see already we have restricted access. So you need to have the administrator password to get in. So I know it's password 123. And one of the beautiful things your Cisco iOS does, it doesn't even show you how many characters. That way somebody standing behind your back would know if it was 3 characters or 30 characters that you typed in, unless they look at your keyboard and are real vigilant. So now I have protected that mode. Yeah. But there's a little hiccup. This is the most basic form of protection. And I refer to it as a basic form of protection because even your password is saved in clear text in your configuration file. So, and to show that, I can view my running configuration file. The running configuration file is the place where Cisco stores all the configurations you're doing until you decide to make it permanent by saving it. So I'm going to say, show me my running configuration. And I want you to include the word, only the lines that have the word enable. So this shows me the configuration I made in my file. Notice how it is stored, right? It actually shows you the password in that configuration file. Now, granted, for you to see this, you need administrative privileges anyway. But what if an attacker was able to get to this file because you access it through HTTP, for example? They don't need passwords to snoop your file. Many of you have used Wireshark, I'm sure, which is a program that lets you sniff your network. They would see your password simply because it's going in an insecure medium. Or if you connect it through Telnet, for example, they capture those files they'll be able to see the password without having to log in. So what we want to do, we want to mask this information while it is stored in my configuration file. Even better yet, instead of use my enable password and then password 123 command, we have another command that automatically hashes the password right there in that file. And it's the enable secret command. So I'll say enable secret 123. So it's almost like your enable password command. Let me go into my Google configuration mode to do that. So it's almost like your enable password 123. It's just the word is secret, but notice the big difference. I'm going to go now and I'm going to tell the system to display my global configuration file again, which is that place where it stores information, right? So let me get back from that user mode to my enable mode. And this is another security feature that you would notice. Now that I have configured enable password 123 and enable secret 123, how is the system going to react? What's going to be the password to get into this system? Of course, the password is going to be your second one because it's stronger, it's more respected, it's more protected than the first one. So I'm going to type in password 123, already timed out. Let me go password 123, and it refuses that password. Of course, the reason being I've configured both enable password and enable secret. Now I type in secret 123 and I'm in. Good deal. We've made our system even stronger, a better, stronger password. How do we know it's a better, stronger password? I'm going to say, show me my running configuration and still include any line that has the word enable. Now I have two lines. The first line is the one below. That's that enable password command I ran earlier. It's stored in my current file. And look at that second password. I said enable secret 123, but what do we see here? A hashed. By the way, the system has decided to use a hashing protocol for me. And it tells me the type of protection is done, the level of protection. We're going to get to that shortly to show you the level of protection you could do. So this is why your enable secret is a better command to use. Again, remember what you're doing. You're protecting that privilege mode so that if someone walked in front of your router, they just don't connect a cable and start configuring your router. Yeah, they'll be able to get into user mode, but they would not be able to view configurations unless they know this password. Now, what if I didn't want to use enable secret? What if I wanted to use enable password for whatever reason? As I mentioned earlier, another option you have is to come into this file, my running configuration file, and then protect that entire file or protect that line. This is actually a good command to know because there are some other passwords of which they don't have secrets. In other words, it will be in clear text. So there is a command called service password encryption. This command goes into your running configuration file and protects any password that's in clear text. Notice what happens. So I'm going to say show run. As a matter of fact, I'm not even going to type. Let me hit my up arrow and repeat that last command. See what happened? My system protected that password file and it gave me a level of protection that it did. Again, we will get to that number and what it is. You've just learned one way to protect your privilege mode, one way with the basic command and with the higher command. The result of this, again, someone walks in front of your device and what are they going to do? If they walk in front of your device, they're not going to be able to just go in and start running configuration commands because they've downloaded it and seen it in YouTube, right? They would have to be, they must know something about the password. So you would have to give that to them probably. Let's get back to the sharing. I'm going to have to get used to switching desktops back and forth. So bear with me as well while I do that. Okay, selected, go to share. There you go. That's more like it. All right. So that was protecting your privileged exec mode. Let's see the progress we're making already. So still on your course, we're going to look at securing your console access. First of all, what is console access again? As we had mentioned, that's when you have physical access to the device. At the back of your router, usually you see a sky blue port that has a special connection. Sometimes it's a USB, but your console access is right there, physical access. So if someone had a hold of your router or your switch, they would connect to that console and signals will travel through that port. That's, of course, a vulnerability, right? Because even though they can only go to user mode, you may not want them to see anything about your router unless they are permitted to. So now we're going to protect that port. Even though it's a physical port behind, we're going to block signals from going by forcing someone to put in the password before those signals can go through. So we would see how to configure that console access. So let's see, I'm going to switch a little bit back, get back to my command prompt. All right, so how do I protect that console? Because that sounds a little scary there, especially since we have no cameras where our routers are stored. So config T, the command to get into my console is line console 0. So I'm in my console line. Command number 1 for protection, your login command. So this login command says I am turning on a login feature. When I do that though, the system gives me a little warning. It says, hey, look, even though you've run the login command, login is not enabled yet until you give a password, because how are they going to log in if they don't have a password? And I'm like, you know what? You're right. Let me run the command. Password, and I'm going to say console 123. All right. So password console 123 takes me into this mode. And actually, I don't want this terminal to time out. So I'm going to add a command, which is not forcefully necessary for security. You may even argue that this, depending on the number I put in here, is not the best option. But I'm going to tell my system to at least let this console be on for 5 minutes. After 5 minutes of inactivity, kick them out. That's good for security. Because sometimes you connect to the console, you start browsing the internet, watching a YouTube video, and you forget. You don't want someone to just come over and use that console after you've put in the password. So now I've made it time out after a certain amount of time. Let's now see the advantage of what we've done. First of all, let me check my running configuration, right? And I'm going to say, oh, show me the configuration I've done somewhere, but only show me the section for my lines. When I hit that, there goes the command. So this is what I've done so far. Going to my line console 0, I set my exec timeout. I only typed 5, but the system added a 0 there. Yeah. So he's able to do your 5 minutes for your protection. And then you have the password. Because I had set the password encryption command, notice what happens. It automatically hides that password for me. So that unless I tell you, you can't, even if you have an access to this running configuration file, you wouldn't be able to see it. The system itself put another command called login synchronous that just allows that if a message pops up to the screen while I'm typing, let it not override my typing screen. And then you have your login command, which is what I did. Notice it put it in the right order, right? It puts your password first and login, even though I typed it in the reverse order. All right, well, that's good. Well, tell you what, I'm going to log out because I had logged into the system. This is what you see normally when you connect to your device. It says R1 console 0 is available. Okay, well, let's test that. I hit my enter key. Awesome. So now you're seeing console protection. Before, when I hit enter, it took me straight to the greater than sign, the user mode. I can't go to the user mode now. Those signals are not going through until I type in console 123. All right, I'm in now. Protect my enable mode. Got to put in secret, right? Because it was the better one than password 123. So secret 123. Okay. All right. So we're in. And that is protecting your console mode. If you paid attention to the slide, the third option that was there was how to protect your virtual terminal or remote access, because that's the other way that someone can use to access your device. Yeah, so they can go in through remote access. So that's our third point. What are my remote access options? Well, you have Telnet, been around for a very long time, traditional program. Not everyone's a good friend because it sends all information in clear text. Then you have Secure Shell, which Secure Shell is able to protect the data using encryption. So it can encrypt the data. We're going to see how to configure remote access using Telnet and also Secure Shell. If you chose Telnet for compatibility with older routers or in an environment where they can't handle security, or if security is not a concern because it's going through a tunnel maybe, you could configure Telnet, a lot easier to work with. But Secure Shell works already natively with your router. So we're going to see then how to configure that and see if I can get back to my device. All right, so commands. You go back to global configuration mode, line VTY 04. Again, I'm not paying attention. I run login. The system is like, come on, I just told you last time. Login is disabled until you run the password command. And I'm like, sorry, I'm learning this thing. It's not so easy. So, okay, fine. Fortunately, it accepted it. It just didn't enable it. So I'm going to put a different password. What have I just done? I'm protecting the first 5 lines on my remote access. So if someone wants to hit my router through the network, they have up to 5 lines. My first 5 lines have been protected. You have to put in a password before you can get in. That's what I'm saying here. I'm going to also be a lot less friendly now, because that 5 minutes seem to be a big deal. Looks like I'm having some messages there. Check them out in a little bit. So exec timeout. Now I've set it to 30 seconds for the timeout screen. Give me a moment. Okay. All right. Sorry, I had to check the messages. It doesn't quite display it immediately, so I have to switch to do that. Okay, well, back to the training. Exec timeout, 30 seconds, right? Because last time I said 5, and that was 5 minutes, 0 seconds. Now I'm saying 30 seconds is all you get. If you don't type for 30 seconds, let it disconnect you. That seems pretty fair to me, because I don't want someone connecting from home and someone exploiting that. So let's test. I'm going to switch now. And we're going to see the results of that. Of course, if we're configuring remote access, we need to go remotely. All right, let me get to my terminal. Back to this PC1 remote access. We're going to telnet. I know the IP for this. I think it's 10.10.1.1. I'm going to use the telnet program from this PC to get there, which means I would have to share that view as well. So give me a moment. All right. I know I'm on my PC because it says PC1. So here we go. It's telnet 10.10.1.1. All right, line open. Now it's asking me to log in. All right, so it's open and I'm in. Well, it looks like connection to 10 closed by foreign host. So it didn't quite work. Let's do that again. Sometimes enough packets don't go through, so you have to try it again. If it worked, it should have asked for login. There we are. So VTY pass. Okay, so I've protected my router to my first terminal. So up to 5 people are going to get asked to put that password in there. So I'm going to say in. My enable mode is still protected, so I have to secret 1, 2, 3. And then I'm in config T. Okay, we're going to add up a secure. We're going to step up security because right now we are all logging in using the same username. We just put in the password. So I want to change that. I want to create actual usernames for those that are going to be logging in. So through my telnet line, I'm going to say I'm creating a user called admin, and they're going to have a secret, so protected password. It's going to use SHA-256. Notice my options, right? I can do secret 0, in which case it will be an unencrypted secret. Secret 4, which means it will use SHA-256 to hash that data. Secret 5, which will use MD5 as a protection. So if I don't mention any, as you saw earlier, it'll choose 4, which is a better option. So I'm not going to put in any secret. I'm just going to say my secret is Cisco 123. All right, so I have created a user. Now that's another level of protection that's even better because now you have to put in a username and a password. Let me make sure I typed it in well. So I would say include my user command, only show my lines that have user. Yep, there you go. See, 4 and protected. Now let's test it. I'm going to go to my router 1, or in here, I'll say line VTY04. Even though I'm connected through telnet, I have to run a command called login local. This command allows the system to now ask for password. I'm going to remove my old password that I put in before with the no password command, and then I'll leave out there. Let's go test it. So let me exit. All right, so back to my telnet. I'm going to say telnet again, 10.10.1.1. And now you notice it's asking for a username and then the password Cisco123. So I'm in my router now. So we've added a level of security where you have to ask for a username now and not just everyone knowing the same password. So I can go in, line VTY04. So exact timeout, let me make it 10, right? Because 30 seconds was kind of harsh. Okay, so notice that even from within the telnet, I'm actually configuring telnet. So it's definitely something you want to protect. Now, I'm going to log out. That's telnet though. What if we wanted it to be a little stronger? So secure shell. How do we protect secure shell? So let's see. Let me switch back to my router 1. Let's see if that's PC1. Let's see what this is. Where is this? Oh, this is router 1. All right, so and to the console. So Cisco 1, 2, 3, hit enter, user access verification. All right. Let me go back and check what password I give to my console line. All right, so it's console 1, 2, 3. There you go. That's more like it. All right. So real quickly, we're gonna now see how to configure secure shell. Right. So enable secure shell, configure it as well, and then we can move on to our last set or talk about the next security. So all right. So configuring secure shell. So what do we want now? The password for enable, which is secret 1, 2, 3. There we go. Configure T, IP domain name, ICND, that lab. So you have to give it a domain name as long as it's spelled properly. Go back and fix that right there. All right, so first command, I'm going to turn on encryption with crypto key generate, and I'll say the algorithm I want to use is RSA. How strong is the key? 1024. It says all right, we're good. All right, so I'm going to say IPSSH version 2 because version 2 has fixed a lot of bugs that came in with secure shell, and I've turned that on. All right, I'm going to go back to PC1 now, and that way we can see how to use the telnet share. Oh, my PC1. All right, so on PC1, say telnet 10.10.1.1. As for username, again, admin, Cisco 1, 2, 3. All right, so I'm in, right? So telnet works. Now to use secure shell, admin .1. The admin is the username I want to log in as. If it works, if it finds that server, the next thing you should do is ask me for my password. So I'll say Cisco 1, 2, 3, which is what I put in, and I'm in. So to configure secure shell, give it a domain, you set up secure shell. Now it's an even better protocol. So now that we know secure shell works, what we're going to do, we're going to disable telnet because we don't want that running at all. So I'm going to go in and say enable, then secret 1, 2, 3. That's the password. All right. So I'll now go to my global configuration mode. Go in and then line VTY04, which is my virtual terminal line, the first 5 lines of those. Now I'm going to say transport input, and I'll specify only SSH. Yeah. So that there, I'm saying I only want to do SSH, which is another level of security. now securing your remote access to it. So let me log out from there. Now I'm going to try telnetting again. So telnet 10.10.1.1 and hit enter. See, it says connection refused. But secure shell -L admin 10.10.1.1 should allow me with Cisco 123. Okay. So you have prevented telnet from running. It's been denied now, but secure shell, it's still running. Now, what I'm going to do for the sake of time, instead of demonstrate all like I would have liked to do, we can continue to talk about all of them and move on with the training so we can cover the entire topics that we plan to. All right, let's see. So back to my Safari view. So that was your first section. You've seen how to protect that alone. It's good enough because then it protects your entire access to your router, right? So we're here. Are you able to see a screen that has my router and PC head and things like that? Or are you seeing the slides?
No, not really. We are seeing the Cisco Learning Network Space screen.
Okay, let's see. Let me try to go back to, actually, you know what? I'm gonna share the whole desktop.
Yeah, that's probably best. There we go.
Or I didn't. Okay. All right. So the next thing, your next lesson is how to secure unused ports. All right. Now, why is this important? It's absolutely necessary because in your switches, you would have 24 ports, 48 ports, and every one of those ports are hot. They're ready to take in signals. They're ready to do work. And an attacker can very easily get physical access to that switch, and then through that, sending signals. So you just connect their laptops, and they start using your network and communicating to your network, capturing packets and sending packets as well. So it is possible to do what we call port security. So what are we going to look at? We're going to see, first of all, how to disable an interface. So if you have 24 ports, how to prevent them. I'm going to go through the command itself, and then, or we're going to see the commands themselves. Then after that, we'll talk about the different ways that you can protect your ports, static ports and dynamic ports. First of all, how to disable an interface. I'll show you the command, but it's simple. You go to the interface and you run in the command disable, because enable is a command that turns it on, or shutdown. You run your shutdown command rather. So your shutdown command shuts that port down. You need administrative privilege to be able to turn that back on with the no shutdown command. Now, when you're implementing port security, the idea is to tell the system which MAC addresses are allowed, how many are allowed, that way, and to what ports they are allowed, so that if a device connects to a port that you didn't allow it to, it should perform a certain action. So the different options you have static configuration. With static, you're going to go in there and put in the MAC address, and then you're going to say this is the port. With dynamic, what your system does, you would set a maximum number of ports. So you say on this port, on this switch, I want to allow only 5 devices to connect. So the system keeps track in its MAC address table of how many devices have been connected to that port. If it goes past 5, before it gets to reset the information, it'll block the 6th person. Or if that port is going to a switch and that switch has 6 devices, only 5 of those will be allowed to connect to that port. That's dynamic. You can do static and dynamic, where you would say, okay, I want to allow 4 ports, but I'm going to tell you 2 of the MAC addresses so that the other 2 have to be automatic. Everyone's favorite is sticky learning, because everything works smoothly. All you have to do is run the sticky command. And when you run the sticky command, you tell the system the maximum number of Addresses, maybe you would say maximum 1, which is also a favorite number. So you go to a port, you set it to sticky. Why are you doing it sticky? Because sticky allows the system to learn the MAC address. Yeah. Now you don't have to know the MAC address of the device that's connecting. It will learn it and then stick it to that port as if you put it permanently. When you save your configuration, it stays in there. And if you say maximum of 1, that's the only device that can connect to it. So imagine someone in the cubicle, they have a desktop, right? They bring their laptop because they want to do some work and they think they can just jump into the company's network and get internet access. No way, because they have a different MAC address on their laptop. So when they connect to that and connect to the wall, the system will shut it down. It'll restrict it. So that's the option of port security. Now, what actions? I've talked about the shutdown action, but that's not the only action. One of them is to protect. With protect, it'll just prevent the signals from going through. It wouldn't warn anyone, wouldn't pop up any message. It'll quietly reject it. Now, that's a very sublime way of denying, because no one gets any information. They just don't get access. The next level up is restrict. With restrict, yes, it prevents the traffic from going through, but it also logs the information so that you can get notification on your screen. Everyone's favorite, shutdown. With the shutdown option, it prevents traffic, it logs that there's been access, it increases the count of the violations. This increases the count of the violation as well. This doesn't. It increases the count and it shuts down. Now, when it shuts down the port, you have to physically go to that port and then you have to run the shutdown command, because it goes to a state of error disable. So you have to leave from error disable, you have to run the shutdown and then no shutdown to turn it on. So that's your port security for this option. Now, maybe we can take a quick look at those. So instead of demonstrating it, I can go through the command and then we can talk about some other options in the few minutes that are left. So let's see. So on implementing device hardening, we take you to a lab environment, right? So some of the commands. The command, here we're going to interface 01. Switch port security, MAC address, sticky. We've chosen that option. We had all the other options, right? Dynamic, manual, or you say MAC address, you put the MAC address, that's manual. MAC address, dynamic, and then in the next command, you'll run the same command and say the maximum number of MAC address allowed, but we chose sticky. Switch port mode access. The reason we're running this command is because switch port security only works on access port and trunk ports. It does not work on ports that have set to dynamic negotiate, like for full duplex and half duplex. So you have to say what that port is for. Access means it's going to be connecting to an end device, like a laptop. Meanwhile, trunk means it's going to be connected to another switch and carrying VLAN information. This turns on the program, port security, and then that's it. We save our configuration so that when we say show port security, it will show us that this port security turned on, there's been no violations. We can even run the command for the actual interface, so it shows us the MAC address it's learned and the VLAN it's in. So that's what sticky is all about. It learned that automatically. Right? So how easy it says here, you go to PC1, send your MAC address, fake your MAC address because it's no longer what it was. And as you see, the action to take is to shut down. So yes, indeed, first of all, you get notifications on the screen that tell you, oh, there's been a violation. This MAC address is violated and not supposed to, and they have, and you know what? I already have my sticky MAC address, and this is the person that caused the violation. So you can see what device was trying to connect in there. So that's one form of security that's available to you. The next thing we said we'll talk about is controlling access using access controllers. Access controllers work as a security guard or as a bouncer when it comes to protecting your network. You imagine with a security guard to stand in the door, you have to have where you're going proper identification and permission to go there for you to get through. There are two types of access control lists. You have a standard access control list, and then you have an extended access control list. The standard access control list blocks on layer 3, your IP layer. So either this IP address is allowed or not. Right? You have your security guard standing by the door, looks at your ID and says, nope, you're not old enough. You cannot come in here. You're not allowed. Or your name is not on the guest list. You're not allowed. That's how standard access control lists work. Extended access control lists are able to verify all the way to layer 7 of your OSI layer. So what does that mean? First of all, it'll go to layer 3 and check and say, yeah, you know, you are 21. And your name is on the list, but you know what? You're not allowed to come in here with that outfit. So even though you're permitted, the outfit layer stopped it. In other words, checks for the IP address and say, okay, that's good. It looks and says, TCP, are you allowed to perform TCP transactions? Yes, you are. But you know what? You're not allowed to do Telnet though. And that's what you're trying to do. If it was HTTP, I'll let you in, but it's Telnet, so I'm not. Right? So it checks all of those credentials. Now, the other thing that it can do, the next thing you do in configuration with standard access control is you set them up. Then now you go to the port itself, where you're going to put the security guard or the inspector, and then you mention what direction they should change. They should stand to verify traffic. Can you imagine if you paid a security guard to check for entry, but instead of standing outside, they stood inside? They'll be checking everybody trying to go out, right? And people will be going in that are not supposed to go in. Same thing with the router. You have to specify what direction the interface should be examining traffic on. Outside means everyone that's not in my network. Inside means everyone that's in my network. We had seen earlier on options for AAA or options for authentication. We saw that you can create a username on a router. Then that user comes in, put in their name, admin in our situation, password 123, and then they come in. However, that seems very stagnant, very static. There is a server called AAA that's able to do authentication, authorization, and accounting. So it can check your ID, so to speak, make sure you're allowed, and then let you in. It's a way to automate user management. Now, AAA servers, they can actually work with local authentication. The way they work, they create a database of who is allowed and their accounts and their passwords and whether they're allowed to go in or not. That's your AAA server. You can configure a AAA server to work with accounts that reside on that router or that switch so that it will be the service performing the work. Here is how most of us like it. We configure it with a special server called a radio server. Radio stands for Remote Access Dial-In User Service. It's like a central server that's able to connect you to an authenticating server like Active Directory, an authorization and accounting server as well. That radio server allows multiple forms of connection. So when you set up radios, you can have AAA as its client. You can have your Wi-Fi hotspot as its client. If you're still using dial-up for whatever reason, you can have dial-up as well as its client. So that when you're doing management, you only go to one central place, create the user accounts there. If you're going to set up IT policies, for example, the Active Directory, you go ahead and set it up. And then now you have an even elevated form of authentication so that when you're trying to log into your router, the administrator of the router, I don't even have to create user accounts. I'm just going to configure AAA to forward all authentication requests to the radio server so that when you put in your name, you better put in a name that exists already in my domain environment. Maybe the same name you use to log into your laptop when you work. If you have permission to use the router, it will automatically let you in. So you are able to have an even higher level of security that way by specifying the username and passwords. Now, in 1 minute, I can tell you about network address translation. That's another option you have for security. These options your AAA, your radio server, allowed to have an extended level of protection where you can check not only for the username and password, whether they're allowed to perform service. So you can have an IT policy that says, yes, you're allowed, but unless your IP address is 192.168.10.4. Yeah. So it can go in an even higher level of security. Now, NAT, network address translation, allows you to mask your local network environment from the public world. There are three types of NAT. There's a static NAT, there is dynamic NAT, and then you have port address translation. With static NAT, you go to your router, you do a one-on-one mapping. You say, when 10.10.4.4 comes to you, translate the name to 200.10.3.4 and send it out so that everybody in the world will see 200.10.3.4. That at least masks it from an attacker so that an attacker will not see the internal structure of your environment. All they see is the 200 network. And so if they were trying to guess other IPs, they'll be guessing 200. Meanwhile, there isn't any. You just translated that 1010 to 200. That's what they see. Dynamic NAT is almost like static, but instead of having one-to-one mapping, you have many to many. So you may buy 4 or 5 public IPs. Those 5 or 4 will be distributed to the first 5 or 4 that come in. So the first 4 people that try to go through that router, you will configure it to translate their address to that dynamic address and send it out. Again, those outside will only see the outside address. They wouldn't see the internal. Our favorite, which makes internet communications possible, is port address translation. With port address translation, you can say, I want this 300,000 machines to all go out as this one IP. How is that possible? It'll assign a port number for every connection. Yes, the attacker sees that IP, so it doesn't even know how to get to the original machine because everyone is using that same IP. And that's what we do when we go through our service provider. They transfer or usually will amalgamate all our IPs to a specific IP that's translated to a public IP that allows us to at least view the internet, even though we're not publishing on the internet. So in summary, you learn how to secure your exec mode, your console, your remote access. We had a chance to see those live. How to harden your device through port security. We talked about those. And we talked about how to implement advanced security with access control lists and local and centralized authentication and radius servers. And we also talked about network address translation. So for the time that we have, I could take your questions, please, for what questions you have. And if you don't, that means I get to grill you for 3 minutes. And I know you don't want that. So you can give me your questions and we can spend time answering those. What questions do you have for me? Yeah,
So
we're
while we
looking.
wait for questions, I would plug Expert Connect again. So guys, Expert Connect is a community of IT professionals like yourself. Do check it out at expertconnect.quickstart.com. And if you have any questions or any queries or anything, just send us an email at marketing@quickstart.com. So we are keeping a close eye on the chat and the Q&A box. Okay, thank you for joining us, everyone. We hope this was as educational for you as it was for me, at least. Great session, James. I'm sure that anyone who's preparing for CCNA routing and switching, especially, they can learn a lot from this. This is on YouTube as well. Feel free to reach out to us through email, and see you guys next time. We'll definitely be doing this again very soon. Thank you, everyone.
Oh, okay, and thank you, everyone, as
Thank you,
well.
James.
All right, thank you.